So we are going to solve this quadratic. The quadratic has two solutions, and we're going to find what those two solutions are. And what we're looking for is negative x squared plus 6x minus 10. What two numbers can I plug in here and get 0? By the fundamental theorem of algebra, because this is to the second power, I should have two solutions. So the way I would start is I would go to Desmos and I would type it in. I like to get a visual before I start. Negative x squared plus 6x minus 10. And so the question is, when does this cross the x-axis? Well, it doesn't in a real number system. So I could say just by the graph, this is what the graph looks like, that the parabola never crosses the x-axis in the real number system. So I might say, based off the graph, no real solution. So I can't solve this by graphing, since they are the solutions are complex, imaginary. Alright, next I'm going to try to solve this using square roots. And the problem with solving this using square roots is I have 1, 2, 3 terms. And so when you have 3 terms that are all unique, you cannot solve. So I cannot solve using square roots, because there are 3 terms. Now if it only had 2 terms, you could solve using square roots. Now I'm going to try to solve by factoring. And remember, anytime there's a negative sign out front, you want to factor that out. So you're going to factor out a negative, and that changes all the signs inside. So that changes that to an x squared. That changes that from a positive to a negative 6x. And that changes that from a negative to a plus 10. Now from there, I have a quadratic, second power, a is 1, so I make the factor x. And I'm trying to find two numbers that multiply to 10, but add to negative 6. So I think, okay, 1 times 10 makes 10, but if you add and subtract 1 and 10, you either get 11 or 9. That won't work. 2 and 5, 2 times 5 is 10. If you add 2 and 5, you get 7. You subtract them, you get 3. So I see that there's nothing that will multiply to 10 and add to negative 6. So I would say this is not factorable. So I can't solve this by factoring. Now I am going to try to solve this by completing the square. What you would want to do, this one's a little different. You would add 10 to both sides. So when you're completing the square, you want to move that number over the constant. And now you get negative x squared plus 6x those go away, and 0 plus 10 is 10. So that's the first step of completing the square. From there, you take this number here, right here, and there's a process. And the process is you take that number, take this number, you divide by 2, and you square it. You take this number, divide by 2, and you square. Now I did forget one little step. I actually need to factor out a negative first. So if I factor out a negative, I get x squared minus 6x so this is going to actually be a negative, but I still get the same thing because if you square a negative you get a positive. But negative 6 divided by 2 is negative 3. You square that, you get 9. So I kind of need the space, but what I have so far is I have negative x squared plus 6x, and I'm going to add something to that. But whatever I add to the left, I have to add to the right. So hopefully this part isn't confusing you. At this, I had negative x squared plus 6x equals 10. I factored out the negative, got x squared minus 6x equals 10. And then I'm going to add a number to both sides. And what number do I add to both sides to complete the square? You take this number, divide by 2, and you square it, so I get 9. So 9 is the number I'm going to add to both sides. From there, I'm trying to find two numbers that multiply to 9 but add to 6. That'd be 3 and 3. And I already knew those two numbers were going to be the same because that's called the process of completing the square. You get the same number twice. So now I get negative x plus 3 x plus 3 and 10 plus 9 is 19. But x plus 3 times x plus 3 is x plus 3 squared. So now I have x plus 3 squared is 19. Now from there, I want to get the square by itself, so I divide both sides by negative 1, and I get x plus 3 squared is negative 19. And then to undo the square, I take the square root. So now I have x plus 3 equals the positive and the negative. Anytime you take the square root, you need positive and negative of negative 19. And that's why my solution is imaginary, because you have a negative inside of the square root. We learned you could bring the negative out. And make it an I. And this is still x plus 3. Subtract 3 from both sides. And you get x equals negative 3 plus or minus I square root of 19. Alright, the final way, and we should get the same result of negative 3 plus or minus I square root of 19, is we're going to solve this using the quadratic formula. And the way you go about it is, you know that A, whatever A is, goes here. And we know that A too big. We know that A, in this case, is -1. So that's going to go here and here. And then we know B would go here and here. And we know B is 6. And then C is -10. And C would go there. So that's all we are going to do is we're going to plug into that formula. This part stays the same though. We have x equals negative something plus or minus something squared minus 4 times something times something all over 2 times something. So that part always stays the same. First, let's plug in the blue ones. So we know A is -1. So I'm going to put -1 here and here. I know B is 6. So I'm going to put B here and here. And I know C is -10. That would go here. Now this part, negative times negative times negative would be negative. 3 negatives make a negative. 6 squared is 36. 4 times 1 times 10 would be 40. So this becomes 36 minus 40, which is -4. So I get x equals -6 plus or minus square root of 36 minus 40, which is -4. And then 2 times -1 would be -2. Now, I could just now realize that I'm not going to get the same answer I did before. And I see why. When I added 9 to both sides, this was actually a -9. So because the negative distributes to the 9, I should have put -9. And 10 plus -9, that should have been a 1. And then when I divided by negative, that should have been a 1. That should have been a -1. That should be square root of -1, which would be plus or minus 1i. So I don't need this part. So I didn't have to change much, but I accidentally did a computation mistake. So that's -3 plus or minus I. And now I could go back here and finish. Taking the square root of 4, we already talked about that. The negative comes out to make an I, and the square root of 4 is 2. So the square root of -4 is 2i. So now I get x equals -6 plus or minus 2i divided by -2. I can divide all three of these by -2, and I get x equals 3 plus or minus 1i divided by -2 would be divided by 1. And notice I got the same answer both ways, because really you don't need to divide by 1. You could just get rid of that. So going through the multiple methods, I found that if you solve by completing the square and quadratic formula, you get the same answer. The reason why you get the same answer is because the formula is derived by completing the square. Whoever came up with the formula did it by noticing the patterns here. Graphing, I couldn't get the solution because it doesn't cross the x-axis, and I couldn't solve by square roots because there were 3 terms.